magnetic field, a distance y away from it.
Doesn't matter if the Y is curved or not?
It matters, yeah. So it has to be a straight wire, infinitely long straight wire. I mean, no wire is infinite, it should just be long enough. So if the wire is a few meters long, and you're just a centimeter or two away, this applies pretty well. So that is that. So let's put in some numbers into this one, just to get some practice. So let's raise this one and drop this. I'm going to so we're going to do an example where we just plug in some numbers. We're going to consider a wire of some current, and we want to be a distance away from it and see what the magnetic field is. So let's say here is a wire. The current is in this direction. And let's say your distance here. The distance R equal to 1 centimeter, which is 10 to the minus 2 meters. And let's say the current is 1 ampere, which is pretty large. Okay. So 1 ampere. So the magnetic field, then use this formula. So you have the magnetic field, we have a magnitude of mu naught I over 2 pi times R, right? I use the symbol Y here, but it's standard to use the symbol R, a distance R away from the current. Anyways, this represents the distance away from the wire. So let's plug them in. Mu naught is 4 pi times 10 to the minus 7 divided by 2 pi times the current, which is 1 ampere, divided by R, which is 10 to the minus 2. Okay. We need to do this. The pi cancels. You get 2 times 10 to the minus what? 5. Okay. 5 Tesla. So, is it large? Is it small? Well, the magnetic field due to the Earth's magnetic field, where the compass needle, because of which the compass needle points north, so the Earth is pretty weak, and it is about 5 times 10 to the minus 5 Tesla. Okay. So it's stronger than this one. The refrigerator magnet, the bar magnet, let's say bar magnet. There is a variety, but let's say typically it's about 5 times 10 to the minus 3. So it's about 100 times that of the Earth. So the current carrying wire, even though the current is pretty large, 1 ampere, it's still very small magnetic field. So a current carrying wire is not the best way to produce a strong magnetic field. Best way is to use coils. You will use a coil, and which is the next thing, which is due to a loop. But then you don't just use one loop. You make a coil that has lots of loops, let's say 10,000 loops. Then you can create a strong magnetic field. And then you have to cool the loops and so on, so that they don't generate too much heat. Yeah.
So if we were saying like there's a circle around the wire and you pick any point around it.
Yeah.
the magnetic field will be pointing away from the wire?
That was, one thing I wanted to point and I forgot. Thank you.
Okay.
So let's say this is the wire. In what direction is the magnetic field, right? The current is this way. The magnetic field, good. Point your thumb in the direction of the current and the magnetic field will circle. So it's going like this. So when you're above, the magnetic field is actually coming out of the board. On the bottom, the magnetic field is, because it circles and then comes back, so it goes into the board. That was your question, right?
Yeah.
Okay. And that's what I wanted to do and I forgot. And I think I will stop. I will stop here. And, we'll continue next time.
Thank you.